Hello and welcome to the Business Analytics with Excel course offered by Simplilearn. This video will give you an overview about the importance of analytics in business today, why it is in demand among a lot of organizations, and how you can effectively leverage Microsoft Excel for data analytics. It is quite clear that businesses must understand the changing market and trends in social media to stay ahead of the competition and drive effective business decisions. What can help businesses maintain their competitive edge? The answer lies in business analytics. The term business analytics refers to the skills, technologies, applications, and practices that facilitate continuous iterative exploration and investigation of past business performance, customer data, and competitive landscape data. The goal is to gain insights and drive business planning. Therefore, business analytics empowers businesses to automate and optimize business processes, thereby enabling them to sustain the competitive advantage. Microsoft Excel has extensive analytics capabilities to perform statistical analysis. With the added advantage of visibility, a flat learning curve, and good reporting functionalities, Excel has become the tool of choice to start your data analytics journey. Did you know Excel offers intuitive analytics features such as Find, Connect, and Shape to model and analyze a company's data? Today, Excel comes with in-memory technology that makes it easily compatible with millions of bytes of data, enabling companies to perform the necessary analysis without being dependent on specialized solutions. Additionally, features such as Power Business Intelligence, including Power Pivot, Power Query, Power View, Power Maps, and so on, easily integrate with Excel. The sandbox-like Excel environment makes data exploration and deriving results quite easy. It includes features to perform powerful data analytics processes with just one click instead of using a complex set of formulas, pivot tables, and manual steps. With increasingly diverse toolsets being added to Excel, it's very clear that Excel is the business intelligence tool of choice and the future of business intelligence workflows, and is being increasingly preferred by analysts, reporting professionals, and BI people. Excel provides a grid-like interface of rows and columns, enabling users to organize and format data better. The data can be simple text, numbers, dates, or other supported formats. Excel's libraries span a large range of functions, from basic math to complex statistical formulae. It cannot be said enough that Excel is pivotal to organizations, as it is the leading user-friendly analytical tool. Amazon, an American electronic commerce and cloud computing company, has been in business for more than 20 years. It has a user base of millions of customers. Ever wondered how Amazon predicts exactly what customers want to buy? It's simple, or let's just say it's simple business analytics that involves understanding the patterns of what happened in the past to predict what might happen in the future. Currently, this is a requirement of every business. Simplilearn's Business Analytics with Excel course introduces you to Excel, the powerful data analysis tool that will enable you to collect data and perform an in-depth analysis of the data to drive effective, impactful business decisions. Designed to build upon the concepts and procedures in data analytics, the primary focus of the course is to learn how to use Excel to perform multivariate statistics and to understand how to explore, experiment, and forecast results with Excel's histograms, pivot tables, statistics, and mathematical formulas and charts. After attending this course, you should be able to understand business problems and datasets, perform calculations using statistical techniques, conduct a variety of statistical analyses, including regressions, covariance, correlation, and testing hypothesis, present and interpret the results of statistical analysis, design dynamic reports and dashboards for business consumption. This highly engaging course features concept videos with exercises which will empower you with hands-on experience. The course covers Introduction to Business Analytics with an overview to different types of analytics, statistical and mathematical functions. After each lesson, practice and revision assessments are provided to reinforce the concepts learned. The course ends with detailed case studies outlining real-life scenarios. Simplilearn will offer complete support anytime during the course or while you're working on the projects. If you subscribe to the live virtual classroom training, you can attend an ongoing batch and revisit important concepts to seek help for the projects. Visit the Simply Learn website, www.simplylearn.com, and click Help and Support at the bottom of the page to submit queries. You can also speak directly to the support staff with the Simply Talk or live chat option. So, are you ready to begin? Happy learning!
Hello, and welcome to the lesson Formatting, Conditional Formatting, and Important Functions. In this lesson, we will learn about custom formatting, how to use conditional formatting and formulas, and implement logical, statistical, and mathematical functions. Let's say we need to differentiate the sales value from the given data set as above target, below target, and met target. As a data set can be huge and complex, differentiating each value manually would consume a lot of effort and time. Here comes the Excel features such as formatting and conditional formatting, which enables us to perform this task easily. Formatting, as the name suggests, helps us to format the data using different techniques, making the data easy to read in the required format and analyze them. The right formatting technique applied to the worksheets can help the users present the data efficiently. Conditional formatting, a type of formatting, helps us visually explore and analyze data, detect critical issues, and identify patterns and trends. Conditional formatting helps to add patterns and trends to the raw information using different colors, icons, and formulae, etc. At times, we also need to perform mathematical operations and calculations within our data set. Excel provides a large number of logical, statistical, and mathematical functions such as VLOOKUP, HLOOKUP, and, if, not, rank, quartile, and many more that can help the users to perform calculations ranging from basic to complex operations. These inbuilt functions help us to manage data and perform descriptive statistical analysis. Excel also offers a wide range of important formulas that help to perform many common tasks. These formulae may be as simple as basic addition, or it could be a complex combination of inbuilt Excel functions. Before going into details, let us start this lesson by defining the objectives of the lesson. The worksheets appear more polished and easy to read if proper formatting techniques are applied to it. We can format the cells in Microsoft Excel manually by selecting fonts, font color, font size, background colors, and borders. We can also use numerous predefined table styles or quick styles to quickly format a table automatically. This is the basic formatting in Excel. If these built-in functions do not meet our needs or do not display the data in the format that we require, we can create our own custom format. In this topic, we will focus on custom formatting in Excel. Let's say we want to display 1,532,000 as 1.53 M, or the 1st of January 2016 date, with a weekday as the first Friday, January 2016. Here we can use custom formatting feature of Excel. Let's see how we can accomplish this in Excel. In this lesson, we shall consider the following fields from our master table: dates, order ID, product, salesman, region, number of customers, net sales, and profit and loss. Here in the given worksheet, we have a column named Net Sales. Suppose we want to display the values of net sales in terms of thousands. For example, 7,164 should be displayed as 7.16K. Select the entire column for net sales. Under the Home tab, click the drop-down present in the Numbers panel. Select the option More Number Formats. A Format Cells dialog box appears. From the category list, select the type as Custom. In the Type text box, enter number, column, number 0, decimal 00, comma, open double quote, capital K, close double quote. Here, number is the digit holder with thousand comma separation. Each comma after decimal 00 indicate divide value by 1000. The 2 zeros after decimal point indicate number of value after decimal places. The K component displays a literal K character to denote thousands. Here we can see the preview in sample box. The value shown is 7.16K. Finally, click OK button. The values in column net sales are now displayed in terms of thousands. Now let us consider another example of date formatting. In the column dates, we have a date value written as 1st Jan 2012. We want to display it as 1st Sunday, Jan 2012. First, select the column containing dates. Under the Home tab, click the drop-down Present in Numbers panel. Select the option More Number Formats. A Format Cell dialog box appears. From the category list, select the type as Custom. In the Type text box, enter DD-DDD-MMM-YY. Here, D stands for date, M stands for month, and Y stands for year. The first 2DD is the date. The next 4, DDDD, is for weekday, say Thursday. Then MMM is for the month in short form, and YY is for year. Here we can see in the preview in the sample box, the value shown is 1 Sunday, Jan 12. Finally, click on OK button. Thus, the custom formatting helps us in changing the appearance of the cell value according to our needs. A worksheet may contain thousands of rows of data. By simply examining the raw information, it would be difficult to see patterns and trends. Conditional formatting helps us visualize data that make worksheets easier to understand. It quickly highlights important information in a spreadsheet by using colors, icons, and data bars. It changes the appearance of one or more cells when the cell value meets certain criteria. To do this, we need to create a conditional formatting rule. For example, a conditional formatting rule can be, if value is greater than 5,000, color the cell yellow. By applying this rule, we will be able to quickly see which cells contain values that are greater than 5,000. Let us understand this with the help of examples. Consider the given sales table, which depicts the amount of sales done by each salesman. Here, we want to highlight the duplicate order ID values. First, select the order ID column. Click Home tab. Under Styles panel, select the option Conditional Formatting. From the drop-down menu, hover the mouse over Highlight Cells Rules and select Duplicate Values. A Duplicate Values dialog box appears. Select a formatting style from the drop-down menu. In our example, we will choose Green Fill with dark green text. Click OK. Here, we can see that the conditional formatting is applied to the column Order ID. Excel highlights all the duplicate cells with green fill with dark green text. We can also explore other options available in conditional formatting, like greater than, less than, between, equal to, text that contains, a date occurring, and top/bottom rules. All these rules work in the similar format. Excel provides predefined styles to quickly apply conditional formatting to our data. They are data bars. Data bars are horizontal bars added to each column, much like a bar graph. Color scales. Color scales change the color of each cell based on its value. Each color scale uses a 2 or 3 color gradient. Icon sets. Icon sets add specific icon to each cell based on its value. Let us consider another example to explain how icon set rules are used. Consider the given sales table. Here, on the basis of the sales amount, we want to apply the icon set rule. If sales amount is greater than 8,000, then a green arrow should appear in the upward direction. If sales amount is between 5,000 and 8,000, then show a yellow arrow in the horizontal direction. And if sales amount is less than 5,000, then show a red arrow in the downward direction. To perform conditional formatting, select the desired cells, click on Home tab. Under Styles panel, select the option Conditional Formatting. From the drop-down menu, hover the mouse over Icon Set Rules and select the first rule. Again, click on Conditional Formatting, select the option Manage Rules from the drop-down. A Conditional Formatting Rules Manager dialog box appears. Go to Icon Set Rule and select 3-Icon Set Rule. Click on Edit Rule, and an Edit Rule Formatting dialog box appears. By default, for 3-Icon Set Rule, Excel uses the 67th percentile and the 33rd percentile rule. This means that it shows a green arrow for values greater than 67%, yellow arrows for values between 67 and 33%, and red arrow for values less than 33%. Now let us customize this rule for our criteria. In the Type drop-down, select the option As Number. In the Value Reference box, enter value as 8,000 for green color arrow and 5,000 for yellow color arrow. Excel automatically picks the criteria for the red color arrow. Click OK. In the Conditional Formatting Rules Manager window, click OK. We can see that the cells are highlighted as per our criteria. Cells which have a value greater than 8,000 have a green arrow in the upward direction. Values between 5K and 8K are highlighted with a yellow arrow, and values less than 5K are highlighted with a red arrow. We can also apply conditional formatting rule with the help of formulas. Consider the given table, which shows the profit done by each salesman. Here, we want to highlight the rows in the table wherever profit is greater than 4,000. Select the entire table along with headings. Click on Conditional Formatting. Select the option New Rule from the drop-down. A new formatting rule dialog box appears. Under Select Rule Type, select the option Use a formula to determine which cells to format. Under Format Values reference box, enter the formula as equals if, open bracket, $H2 greater than 4,000, comma, true, comma, false, close bracket. This will apply formatting to a cell if the profit is greater than 4,000. Click on Format button. From the Format Cells dialog box, select the Fill tab. From the Color dialog box, select the color as green. Finally, click OK. The conditional formatting is successfully applied to the cells. Here, we can see that the cells with the profit greater than 4,000 are highlighted with the green color. Logical functions evaluate a cell or cells for a criteria and returns a Boolean value, true or false. In this topic, we will cover various logical functions like if, and, or, not, true, false. Consider the given sales table. Here, on the basis of the sales amount, we want to determine the commission percentage of each salesman. Following is the criteria. If net sales greater than or equal to 10,000, set commission as 5%. If net sales greater than or equal to 5,000 and less than or equal to 10,000, set commission as 2.5%. If net sales less than 5,000, set commission as 1.5%. This is a common condition where we're required to create a between formula that picks all values between the two given values. In such conditions, we use if with the AND function. Let's write the formula in cell I5. Like any other formula, we will start with the equal sign. Then type our function name, if, and then type an open parentheses. The first parameter we need to pass is a logical test. Here, the logical test is if sales, cell G5, greater than or equal to 10,000, assign value as 5%. Then we will pass the second logical test. Here, we will use AND function. If, open bracket, AND, open bracket, sales at cell G5 greater than or equal to 5,000, comma, cell G5 less than or equal to 10,000, comma, assign value as 2.5%. In the else parameter, we will type 1.5%. This means that if the first two cases become false, then the formula will assign the value 1.5. Finally, close the two braces for the two ifs. Thus, Excel returns the result as 2.5% for cell G5. Now drag the formula with the help of the fill handle. We can see the results for the other cells as well. The OR function returns true if any of the conditions are true and returns false if all of the conditions are false. In the given table, we are required to assign performance remarks for each salesman as per the scaling table. In scaling table, we have the criteria that if net sales greater than 10,000 or profit greater than 5,000, set remark as good. Else, set remark as needs improvement. Let's write the formula using if, and, or to check sales and maximum sales in cell J5. So our formula becomes equals if, open bracket, or, open bracket, G5 greater than 10,000, comma, H5 greater than or equal to 5,000, comma, double quote, good, double quote, comma, double quote, need improvement, double quote, close bracket. Let's drag this formula across the cells with the help of the fill handle. This formula will return true if any of the condition is true. Thus, in the given example, the cell J9 returns good, even if profit is less than 5,000. Our next function is true/false. True/false returns true and false respectively if we write them in any cell. The not function reverses the result of the function. If result is true, it returns false, else true. Let's write formula as equal, not, open bracket, K5, close bracket, in cell L5. This returns the result as false. Let us now study about different lookup and reference functions used in Excel, such as VLOOKUP, HLOOKUP, match, index, and offset function. The VLOOKUP function lets us search for specific information in the current worksheet. Say we have a list of students with marks. We can search for the marks of a specific student. If our table is in horizontal format and we want to determine a specific value, then we use the HLOOKUP function. Consider the extract from our master sales table. The table depicts sales information based on order ID, products sold, salesmen, and net sales. Now we want to determine the net sales corresponding to order ID 1121. Let's understand how we can accomplish this using the VLOOKUP function. Note that VLOOKUP function is only used for vertical tables. Let's use cell I2 to add the formula. Like any other formula, we will start with the equal sign, then type our function name, VLOOKUP, and then type an open parentheses. Now we will add the arguments. The first argument is lookup value. Lookup value corresponds to the value or item we are searching for. So, in our example, it will be order ID 1121, cell H2. The second argument is table array. Table array is the cell range that contains the data. In this example, our data is in cell B2 to E40. The third argument is column index number. The column index number is the column number in which we are looking for information. Here, in our table array, net sales is the fourth column, so our third argument will be 4. The fourth argument is range lookup. This value corresponds if we are looking for approximate matches or not, and can have value either true or false. True denotes the approximate match, and false denotes the exact match. Here we will pass false. Finally, close the parentheses. So our function has the form equal VLOOKUP, open bracket, H2, comma, B2 colon E40, comma, 4, comma, false, close bracket. We can see that the function returns the value as 2277. Note that the VLOOKUP function works from left to right. That means the lookup value should always be present in the leftmost column of our table array. If our table is in horizontal format and we want to determine a specific value, then we use the HLOOKUP function. Consider the given table. Let's write the formula in cell I4. We will start with the equal sign, then type our function name, HLOOKUP, and then type open parentheses. The first argument is the lookup value. So in our example, it will be order ID equals 1121. Cell 84. The second argument is table array. In this example, our data is in cell G8 to AS11. The third argument is row index number. Here, our table array net sales is the fourth row, so our third argument will be 4. The fourth argument is range lookup. Here, we will pass false. Finally, close the parentheses. So our function has the form equals HLOOKUP, open bracket, H4, comma, G8, colon, AS11, comma, 4, comma, false, close bracket. The function returns the value 2277. Note that HLOOKUP function works from left to right. That means lookup value should always be in the topmost row of your table array. The match function searches for a specified value in an item in a single dimensional array, and then returns the relative position of that item in the array. Let us understand its functioning with the help of an example. Consider the given sales table shown. Here, we want to determine the position of the corresponding date in the original table. So let's write the formula in cell E5. Type equal sign, then type the function name, match, and then type an open parentheses. The first argument is the lookup value. So in our example, it will be date in cell B5. The second argument is lookup array. The lookup array is a range of cells that contains the value we are searching for. In this example, we will select the cells B17 to B1342. The third argument is match type. Match type can be either -1, 0, or 1. The value should be 1 if we want to find the largest value less than or equal to the lookup value. The value should be 0 if we want to find the first value exactly equal to lookup value. It should be -1 if we want to find the smallest value greater than or equal to lookup value. Here, we will pass the match type as 0, as we require an exact match. Finally, close the parentheses. So our function should look like match, open bracket, B5, comma, $, B, $17, colon, $B, $1342, comma, 0, close bracket. This returns the value as 3. Now we can drag the formula across cells with the help of the fill handle. Similarly, we can use the match formula in cell E3 to determine the position of the shown field name, cell C3, in range B17 to I17. For example, net sales is at 7th position in the range B17 to I17. Let's write the function in cell E3. Write formula as equal sign, match, and open parentheses. In the first argument, select cell C3. For second argument, select cells B17 to I17. Pass third argument as 0. Finally, close the parentheses. So our function looks like equal, match, open bracket, C3, comma, $B, $17, colon, $I, $17, 0, close bracket. So for profit loss field, the value returned is 8. Net sale, the value returned is 7. The index function returns value from a specified position in a specific column in a list. Suppose we want to determine the value of a field mentioned in cell C3 from the sales table on a specified date. The table should dynamically fetch the value if the value of the cell C3 is changed. If we enter profit loss, formula should fetch the profit loss value for the specified date. If we write net sales in cell C3, then formula should fetch net sales value for specified date. So let's use the index function to determine the value in this worksheet. Select cell C5, write formula as =, index, and open parentheses. The first argument is the array. For our example, enter B17, I1342. The second argument is the row num. This corresponds to the row number that has the value we want to return. Here we will enter E5, which denotes the required date. The third column is col num. This corresponds to the column number that has the value we want to return. Here we will enter E3, which denotes the position of the field name in cell C3 in table. Finally, close the parentheses. Thus, our formula returns the value as 6,528 based on the position at cells E5. This is the net sales value on the date the 2nd of January. Now drag the formula with the fill handle to the other cells as well. The offset function returns a reference to a range that is the offset number of the rows and columns from another range or cell. Now let's understand how to use it. Select cell D5, write formula as =, offset, and open parentheses. The first argument is the reference. This denotes the starting range from which the offset will be applied. For our example, we will select the reference cell as B17. The second argument is the rows. This denotes the number of rows to apply as the offset to the reference. This can be a positive or a negative number. So for our example, we will enter E5 minus 1. Here, we are subtracting 1 to match number of row which have the value and the offset from the reference cell. The third argument is the cols. This corresponds to the column number that has the value we want to return. Here, we will enter E3, which denotes the position of the field name, and subtract by 1 to match with the offset referencing. Finally, close the parentheses. The function returns the value based on the position of date from cell B5 and field from cell C3. Now drag the formula across the cells with the help of the fill handle. If we enter profit loss, formula should fetch the profit loss value for the specified date. A variety of statistical functions are available in Excel to perform calculations ranging from basic function, mean, median, and mode, to more composite distribution and test, binomial or chi-square. In this topic, we will cover various statistical functions like SUMIF, COUNTIFs, percentile, quartile, standard deviation, and median. SUMIFs and COUNTIFs are the most frequently used functions in Excel. These functions allow us to perform count and sum based on one or more criteria. The SUMIFs function calculates the sum of cells based on certain criteria. Let's understand how to use the function with the help of an example. Consider the given sales table. Say we want to determine the net sales done by salesman Justin. Here, we will use the SUMIFS function to calculate net sales. So let's write the formula in cell N4. Type equal sign, then type the function name SUMIFS, and then type an open parentheses. The first argument is the sum range. This is the input range that contains the required data. So in our example, we will select cells H4 to H1328. The second argument is the criteria range. This denotes the range that contains the required criteria. Here, we will pass the range that holds salesman's name, cells E4 to E1328. The third argument is criteria. This corresponds to our required criteria. We only require net sales of the salesman Justin, so we will select cell M4. Finally, close the parentheses. Note that we can pass multiple criteria in this function. The function returns the net sales done by Justin. COUNTIFs function works in a similar manner like SUMIFS. It counts the number of cells in a given range when certain criteria is met. Say in the given sales table, we want to determine the total number of sales for net sales greater than 8,000. To determine the count, we will use the COUNTIFs function. So let's write the formula in cell N5. Type the equal sign, then type the function name, COUNTIFs, and then type an open parentheses. The first argument is the criteria range, 1. This denotes the range that contains the required criteria. Here, we will pass the cells containing net sales, H4 to H1328. The second argument is criteria 1. This corresponds to our required criteria. We only require entries with net sales greater than 8,000, so we will enter greater than 8,000. Finally, close the parentheses. Note that the function allows you to enter multiple criteria. Cell N5 reflects the total number of sales as 445 for net sales greater than 8,000. In this topic, we will learn how to use the functions percentile, quartile, standard deviation, and median in Excel. Consider the given sales table. Let's see how to use the percentile function on net sales to find its 40th percentile. Select the cell N6. Write the formula as equal sign, percentile, open bracket. Select the column net sales H4 to H1328 as our first argument. Pass the second argument as 0.4 in order to find the 40th percentile. This returns the result 5,220. This means that 40% of the net sales is less than or equal to 5,220. The next function is quartile. Quartile function depicts the results for the first, second, third, and fourth quartile. Say we want to find the total number of sales which are less than or equal to 25%. Let's use the quartile function to calculate this. Select cell N7 to write the formula. Type equal sign, function name is quartile, and open braces. Select net sales column H4 to H1328 as the first argument. Type 1 as the second argument. The second argument must be a number between 0 and 4. The function returns the value as 3,822, which means that 25% of the sale is less than or equal to 3,822. Note that here we can use the percentile function to perform the same task. The function percentile H4 to H1328, 0.25 gives us the same result. It's up to us which function we would like to use for the quartiles. Excel has a function to calculate sample standard deviations, STDEV. Standard deviation determines how dispersed the data is from the mean. Say we want to calculate the standard deviation for a number of customers. So write the formula in cell N8 as equals the function name STDEV, open braces. Select number of customers columns as its argument. The function returns the result 1.4. The median function returns the value from the range. For example, we want to find the mid value for net sales. To calculate median in cell N9, write the formula as equal sign, the function name median, then open braces. Select net sales column as its argument. This calculates the mid value of net sales as 6,192. Rank function is used to compare a number from the rest of the numbers in a list in any order, whether ascending or descending. This function returns the rank of the number relative to the other values in the list. Let's use rank function in cell J4 to calculate rank on the basis of net sales. Select cell J4 and write the formula as equal sign, then type the function name rank, and then type an open parentheses. The first argument is the number. This is the value whose rank we are required to calculate. Here we will pass the argument cell H4. The second argument is ref. This corresponds to the array or reference list. Here we will select the column net sales, i.e. cells H4 to H1328. The third number is order. This specifies how to rank the number. 0 means descending order, and 1 denotes ascending order. This argument is optional. If we don't pass any argument, Excel automatically takes the argument 0. Here we will pass 0. Finally, close the parentheses. Here we can see that Excel has determined the rank for net sales, 7,164, as 553. Finally, we can drag the formula and can see the rank for the other cells based on net sales.
Hey, want to become an expert in big data? Then subscribe to the Simply Learn channel and click here to watch more such videos. To nerd up and get certified in big data, click here.